All right, today we are looking at lesson 7.2, day 1. This lesson is found in the purple textbook. Our objective today is to write quadratic functions by when we're given a vertex and a point, or when we're given the x-intercepts and then a point. So we'll be looking at two different methods in how to write quadratic functions. So let's take a look at our first problem. Our first problem, we're asked to write it in vertex form. Keep in mind, as a reminder for vertex form, for a quadratic function is y equals a, open parentheses, x minus h, close parentheses, squared, plus k. We're given that our quadratic has a vertex of -2, 3, and the point that we're given on it is -1, 1. So in order to write it in vertex form, we need to know a, h, and k. Now, right given off, we know h and k because that's our vertex. The h value is the x value of a vertex. The k value is the y value of a vertex. So we know -2 is h and 3 is k. Now we don't know a here, but we do know an x value and a y value because we're given that point. So we're going to be substituting in -1 in for x and 1 in for y, -2 for h, 3 in for k. And then we'll be left with solving for a. So let's take a look at that. So keep in mind, labeling the points sort of gives you a clear map of where you're substituting in what values. So y, which we identified as 1, equals a, keep in mind that's the variable we're solving for, open parentheses, x, which is -1, minus h, which is -2, squared, then plus our k value of 3. Now, here we have an order of operations problem. And inside, -1 minus -2 is really saying -1 plus 2. So we can write this as 1 equals a, open parentheses, -1 plus 2 is 1 squared, plus 3. So we get 1 equals a, 1 squared is 1, plus 3. Solve for a, one-step linear equation, subtract 3 from both sides, and you get -2 equals a. And now we have our a, h, and k value, and we can substitute that in to find the equation for that quadratic with that given vertex and that given point. So this equation will be y equals -2, open parentheses, x minus -2, which we talked about as plus 2 squared, plus 3. So that is your answer. Y equals -2, open parentheses, x plus 2 squared, plus 3. All right, let's take a look at another one together. Same type of problem, we're writing it in vertex form. For this problem, we're given the vertex of -1, -4, and a point on the graph at 0, -3. Once again, we're substituting in -1 in for h, -4 in for k, 0 in for x, and y in for -3 into the function y equals a times x minus h squared plus k. So that vertex form is coming back up. And we're the same type of problem that we did before. We're going to have a as a leftover variable that we're solving for. So this one will be -3 equals a, open parentheses, 0 minus -1 squared, and then minus k. Once again, since that's negative. Once again, we have 0 minus -1, which is really 0 plus 1. So we get -3 equals a times 1 squared minus 4. Now 1 squared is 1, and 1 times a will give us -3 equals a minus 4. Once again, we have a one-step linear equation. Add 4 to both sides, and you'll get an a value of 1. Then to write the equation of that in vertex form, we're substituting 1 in for a, -1 in for h, -4 in for k. So that will give us the equation y equals 1 times x plus 1 squared minus 4. Now since a is 1, I can really write this as y equals x plus 1 squared minus 4. And that is the equation of the quadratic function with the vertex of -1, -4, and has a point on its parabola. Keep in mind, we're looking at quadratics, so this will be a parabola, and has a point at 0, -3. So that's the first type of problem we're looking at today. The second type of problem, they're similar. We're writing an equation, a quadratic, but this time we're going to write it in intercept form. So as we review intercept form, it's y equals a times x minus q times x minus p. And if you remember from when we took a look at that first, our intercepts are the q and the p value. So for this one, we're going to be given the x-intercepts, -2 and 1, and we're given a point on the quadratic of -1, -4. Now it's the same type of setup as the problem before. Here our point is still our x and our y value, although our x-intercepts are going to be substituted in as q and p values. And once again, we'll be solving for a, and then using that to write the equation, that quadratic, in intercept form. So this equation will be -4, substitute -4 in for y, equals a, keep in mind that's the variable we're finding, open parentheses, x, which we labeled as -1, minus q, which we labeled as -2, close parentheses, then open parentheses, x, which is -1, minus p, which is 1. Once again, we have the double signs here. -1 minus -2, we can write as -1 plus 2. So when we simplify this, this gives us -4 equals a, -1 plus 2 is 1, -1 minus 1 is -2. Next line, -4 equals 1 times -2, so give us -2a. Once again, one-step linear equation, divide both sides by -2, so +2 equals a. So once again, for intercept form, we need to know the intercepts and the a value, which we have identified. So we can write this equation as y equals 2, open parentheses, that'll be x plus 2, since it's x minus -2, so x plus 2 times x minus 1. And that is the equation of that quadratic in intercept form with the given x-intercepts -1 or -2, 1, and the point -1, -4. We're going to look at one more of these together. We're writing in intercept form. And this problem, we're given the x-intercepts, -3 and 1, and the point on the graph, -2, -6. So the same type of process, labeling these helps a good bit. This is our q and p value. Keep in mind, you could say that's your p and that's your q. You get the same answer. It doesn't matter. Our x and then our y value. So our equation, once again, is y equals a times x minus q times x minus p. So y, we have as -6 equals a. Once again, that's the variable we're trying to find. Open parentheses, x, -2, minus q, which is -3, close parentheses. Then open parentheses, x, once again, is -2, minus p, which is 1. Once again, we have a double sign here, so I'm just going to write that as -2 plus 3. Next line, we'll get -6 equals a times -2 plus 3, which is 1, close parentheses, then times -2 minus 1, which is -3. Our next line, we get -6 equals 1 times -3 times a will give us -3a. Divide both sides by -3, we'll get 2 equals a. Once again, we have all the information we need to write the equation of that quadratic. We have our a value, q value, and p value. So this quadratic with the x-intercepts -3, 1, and a point on it of -2, -6, we write that equation as y equals 2 times x minus -3, which is x plus 3, times x minus p, which is x minus 1. And that is the equation of that quadratic. Now I want you to try 2 problems on your own. So as you're going through this, you can pause the video, solve it, and then play it, and the answer will be worked out with the description after that. So I really want you to try these on your own. All right, the first one, I want you to write this quadratic in vertex form. When you're given the vertex, negative 2, 1, and a point on the parabola of negative 1, 0. Keep in mind, if you're given the vertex, you're going to be writing it in vertex form. If you're given the intercepts, you're going to be writing it in intercept form. All right, so pause, solve this out, and then hit play to see it worked out. All right, welcome back. Our h value, negative 2, k value, 1, x value, negative 1, y value, 0. Intercept form, just as a refresher, y equals a times x minus h squared plus k. So we get 0 equals a times x minus negative, not x though, you put that as negative 1 minus negative 2 squared plus 1. That becomes plus, we get 0 equals a times 1 squared plus 1. So we get 0 equals a plus 1. So negative 1 equals a. We have all the information we need, substitute in those values. So we'll get y equals negative 1 times x plus 2, x minus negative 2, x plus 2 squared plus 1. But once again, we have a value of negative 1, so I can just write that as y equals negative times y equals the negative, open parentheses, x plus 2 squared plus 1. And that is that equation in vertex form. All right, now I want you to try one where we're writing it in intercept form. So once again, an indicator that you're writing it in intercept form is you'll be given the intercepts. Use those indicators to help you figure out which form you'll need to write them in, and it will be specified, but that's another way you can take a look at it. We have x-intercepts negative 4, 2, and a point negative 2, 16. So I want you to pause the video, solve it out, and then hit play when you're ready. All right, welcome back. We have our x-intercept labeled P and Q, our points x and y. That equation once again is y equals a times x minus q, open parentheses, x minus p. Now once again, you can reverse them. It doesn't matter. That's the beautiful thing about this. All right, so we get 16 equals a times x minus negative 4, open parentheses, x minus 2. Double positives, and I did not substitute in the right values for x, so don't do that. So that will be negative 2. All right, so we get 16 equals a times 2 times negative 4. So we get 16 equals negative 8a. So our a value we get is negative 2. Once again, we have all the information we need. We have our p, q, and a value. So you can write this equation as y equals negative 2 times x plus 4, since it will be x minus negative 4, times x minus 2. And that is the equation of quadratic with the x-intercepts negative 4, 2, and the point negative 2, 16. All right, we'll be going over this in class on Monday. Hope you all have a great weekend, and I will see you Monday.